4.4. Write linear equations in standard form. The standard form is given by ax plus by equal to c. A simply refers to all real numbers, and it also needs to be non-zero. And B also refers to all real numbers, and it is also non-zero. And C refers to the constant, which means any real number. We can take the standard form and rewrite it as slope-intercept form. So I'm going to write it right here. by would equal to negative ax plus c, and this would equal to y equal to negative a over bx plus c over b. The reason why I want to mention about this is because if we just simply look at negative a over b, this will give us the slope of the linear equation. So whenever I'm given an equation, linear equation in standard form, I can simply take the coefficient a and put it over b and multiply by -1. Part A. Write two equations in standard form that are equivalent to the given equation. So one way will be to divide all the numbers, or the coefficients and the constant, by the greatest common factor, which is 9. Another way would be just to multiply all the coefficients by any real number, such as 2, to make it simple. Distribute the 2 on the left-hand side and multiply 27 times 2. And this would be another equivalent equation in standard form. Part B. Write an equation in standard form of the line that passes through the given point and has the given slope m. I will show you two ways to do this, and you can decide for yourself which way works better for you. So the first way, I'm going to use the slope-intercept form to set up my linear equation. Okay, so I'm given the slope. I'm going to substitute in that for m, and I'm going to substitute 5 in for y and negative 8 in for x to solve for the y-intercept. Negative makes positive, so 3 times 2, 6 plus b. Then b would equal to -1. Therefore, my equation will be y equals to -3/4 x minus 1. And then I need to rearrange this to standard form by multiplying by 4. And then move -3x over to the left-hand side. So we would get 3x plus 4y equals negative 4. Now I'm going to show you method 2. So I'm going to first write method 1 and method 2. Okay, so now it gives you that the slope is negative 3 over 4, and earlier I told you that negative a over b will give you the slope of the linear equation. So I can set negative a over b equal to negative 3/4. And I can cancel out the negative sign. And I know a will refer to 3 and b will be 4. And now I can take the standard form, ax plus by equal to c, and I can substitute in 3 for x and b for 4. Now I need to solve for c now by plugging in negative 8 for x and y for 5. And this will be negative 24 plus 20, and c would equal to negative 4. So let's take this up here. Therefore, your equation would be 3x plus 4y equal to negative 4, which is the same as this one. Part C. Write an equation in standard form of the line that passes through the given points. So this one I'm going to find the slope, negative 3 minus negative 1. And then 9 minus 5. So negative 3 plus 1 will be negative 2 over 4. This will be negative half. And then now I'm going to use m equals negative a over b way to find my equation of the line. I'm going to set this equal to negative half, equal. So write ax plus by equal to c. My a is 1, so just simply write x. B is 2. Okay, and then I'm just going to use this point. 5 plus 2, negative 1 equal to c. 5 plus 2 times negative 1 gives you positive 3. So c is 3. Then now I can write my equation of the line as x plus 2y equal to 3. And you can plug in any of these 2 points to double check. So 5 negative 2 gives you 3. Check. 9 plus 2 times negative 3 is negative 6. Gives you 3. Check. So this is the answer. Part D. Write equations of the horizontal and the vertical lines that pass through the given point. Now, if we just graph this point will be about right here, negative 9, negative 3. I'm going to plot this point to show you. So here, the horizontal line would just be this one. So this would be y equal to negative 3, and the vertical line just be, so this would be what? X equal to negative 9. So we can write our answers as x equals to -9, y equals to -3. Part E. Find the missing coefficient in the equation of the line that passes through the given point. Okay, so now we're given a point and we can simply substitute the point in. So I could substitute 3 for x. That would be a 3 plus 4 -1, which goes to 2. And then 3a would equal to 2 plus 4. 3a equals to 6. A would equal to 2. Part F. Write an equation in standard form of the line shown. Okay, so first I need to determine the slope. You can either use the slope formula, or you can just read the slope from the graph. So I could start with this point, 1, 1, and then count 3 units down, so I know my change in y will be -3, and then 1 unit to the right, my change in x would be +1. So I can set this equal to -a/b, and then cancel out my negative sign, so I know a would be 3, b would be 1. So ax plus by equal to c. I will sub in 3. B was just 1. Okay, so I'm going to use the easier point, 1, 1. 1 plus 1. And c would equal to 4. Therefore, my equation of the line in standard form would be 3x plus y equal to 4. For the following word problems, you will need to think about how to use the standard form as a way to solve for your answers. Okay, let's first take a look at the first one. Your class is taking a trip to the public library. You can travel in small and large vans. A small van holds 8 people, and a large van holds 12 people. Your class could fill 15 small vans and 2 large vans. A. Write an equation in standard form that models this situation. So we can let x equal the small van and y equal to the large van. Okay, and we know that for the small van, it holds 8 people, so we can let that be 8x. And the large van holds 12 people, we can let that be 12y. And we can add that together and set it equal to c, which c will be considered the total number of people, but right now we don't know what c is. So the last sentence here gives you your class could fill 15 small vans. Okay, 15 small vans and 2 large vans. So this would be a point given to you. So I can plug it in for x and also for y. So 120 plus 24 equal to c, and we have c would equal to 144. Therefore, our equation will be, in standard form, would be 8x plus 12y equal to 144. Part B, graph the equation in part A. So I've already have the graphed for you. So the x-intercept should be 18, 0. So let's double check. When 12 is 0, x should be 18. And when x is a 0, y should be 12. So yes. Okay. Part C, list possible combinations of small vans and large vans. So I'm just going to pick two random points here. 2, 4, 6, 8, 10, 12. 2, 4. So this would be 12, 4, and 2, 4, 6. 2, 4, 6, 8, 6, 8. So we can say 6. Let the x-axis be small vans and the y-axis be large vans. So 6 small, 8 large. 12 small and 4 large. So you can list more if you like, but this is good enough. Nine pounds of mixed nuts containing 55% peanuts were mixed with 6 pounds of another kind of mixed nuts that contains 40% peanuts. What percent of the new mixture is peanuts? So let n equal the percentage that are peanuts. So my strategy here is to use the standard form to help me solve this word problem. Now, in the beginning it says 9 pounds of mixed nuts contains 55%. So 9, 55 over 100. And this was mixed with 6 pounds of another kind. So we're going to have to add them together. That contains 40% peanuts. And what percent of the new mixture is peanuts? So I need to take n over 100 and multiply by the mixture, 9 plus 6. So this makes sense here. We have 9 pounds plus 6 pounds, and here 9 plus 6, and what percent of the total number of pounds would be peanuts. So I can go ahead and multiply the entire equation by 100 to cancel out the 100 in the denominator. 9 times 55 gives me 495. 6 times 40, 240, and this would be 15n, and here 735 equals 15n, and when we solve for n, it should equal to 49%. You are working in a chemistry lab. You have 1,000 millimeters of pure acid. A dilution of acid is created by adding pure acid to water. So this just means, dilution just means adding pure acid with water. A 40% dilution contains 40% acid, and therefore the rest of the 100% would be 60%. So I'm going to draw a picture to represent the situation. So the dilution with 40% pure acid, and 60% water, I can let X equal to the amount of dilution 1, or the dilution with 40% acid. And here it says you have been asked to make a 40% dilution. So you're going to make this dilution and another dilution that contains 60% pure acid. So I can draw another picture. So this one contains 16% acid and 40% water. Now we're not really concerned with the water part, so let's just set that aside. So this one I can let Y equal to the amount of dilution for 60% acid. So here goes part A. Write an equation in standard form that models the possible quantities of each dilution you can prepare if you're given or using all 1,000 millimeters of pure acid. So I can take 40% or 0.40, multiply it to X, and add it to 0.60 times Y, and set that equal to 1,000. And this equation models all the possible quantities of each dilution you can prepare when you're given 1,000 milliliters of pure acid. Part B. You prepare 800 milliliters of the 60% dilution. How much of the 40% dilution can you prepare? So I'm going to recopy the equation that we came up with in part A. Now it gives us that we're going to use 800 milliliters for the 60% dilution. So I can sub in Y for 800. So 0.60 times 800 is simply 480. And 0.40x equals to 520. Then x would equal to 520 divided by 0.40, and after we simplify this, we should get 1,300 milliliters for the 40% acid. And this concludes our lesson.